Hello everybody, so in this video we will be looking at the LeetCode problem 18, that is foursome. So the problem statement states that we are given an array nums of an integer. So we have to return an array of all unique quadruples. So we have a num of a, num of b, num of c and num of d such that their sum is equal to a target, and all these index a, b, c, d will be between 0 to n. So what we are given, so if we see the example, so for example if this is our array, so our possible answers will be 1 0 0 minus 1, and if the target is 0, then our another possible answer will be minus 2 0 0 and 2, and the another possible answer will be minus 2 2 1 and minus 1, and we can return this answer in any order. So how we can do this question is, suppose this is our array we are given, so we can do something like this. This is my index 1 2 3 5. So what we can do, this is my I, we will first sort the array. So we will sort the array. So when I'll sort this array, I'll get something like minus 2 minus 1 0 0 1 and 2. So this is my I, this is my j, and this is my k. Now what I'll do, this will give me a sum of minus 3. So for this rest of the array, I'll run a binary search and search for the value that is target minus this sum, so that is 0. So I'll search in the rest of the array that can I have a value 3, so it will be 0 minus and minus of 3, which will be 3. So can I get a value 3 in this remaining array? So I can't, so I'll move my k. So again I have something like this. My I is here, my j is here, and now my k is here. So now the sum is again minus minus 3. So we will again check that can I find a 3 here? So I can't, so my k will move here, then my k will move here. So when my k will move here, I will have something like minus 2 minus 1, and the sum will be plus 1, and the sum will be something like minus 2, and then I have to find in the remaining array that can I find a 2. So I can find a 2. So this is one of my possible answers. So I'll put nums of I, nums of j, nums of k, and nums of this mid value into my vector, 2D vector. This way we will do this. So the time complexity, if we do it this way, will be something like there is a loop for I, there is a loop for j, and there is another loop for k. So it will be n cube directly, and then we are doing a binary search on the rest of the array, so that will be a log n. So the time complexity will be n cube log n, and the space complexity will be O of 1, that is the constant space. So now can we do it in a better way? So for the example, I was having 1 0 minus 1 0 and minus, so I was having 1 0 minus 1 0 2 and minus 2. So can we do it better? Yes, we can. We can reduce that log n in the end. How we will do that? So first of all, we again sort this. So for sorting, it will be taking a n log n if we do it using the STL sort, and if we use another sort, so there might be some changes. For example, if I use a counting sort, I can do this in a O of n space, O of n time, but O of n space as well. So if I sort this, it will take n log n. So what I will get after sorting it is minus 2 minus 1 0 0 1 and 2. So this is my array at the moment. This is what I have, right? So now we know that our array is sorted, so we can think of something. So I will have my I here, I will have my j here. So my I will have 2 pointers, left and right. So I will apply 2 pointers approach on the remaining array. So my left will start from here, always from j plus 1, and my right will always be n minus 1, where n is the size of the array, and the sum of these two is something like minus 3, right? And my target is 0. So now what I have to find is 0 minus minus 3, which is equal to 3. Now I have to find can I get, so now I have to do something like that can I get a sum of 3 in this array? So I'll start from my left and I'll do my nums of left plus nums of right. So I'll add this and this. So is it 3? Is it 3? No, it is not 3. It is 2. It is 2. Now 2 is less than 3. So if it is less, I will move left one step ahead. Right? I will move left one step ahead. So this comes into being because we have sorted this. So we can do this because the values on the left side will be smaller and the value on the right side will be greater. So if the sum is less, so I can move from the smaller side to the bigger side, and if the sum is greater, I can move from the greater side to the smaller side. So now again I see, okay, it is again 2, so my left again goes here. Now I am pointing, my left is here, my right is here. Now I see, okay, my sum is equal to the target I was looking, that is 3. That is 3. So I can insert all these values, that is I, j, k and ij left and right into my answer another vector, and then I can insert it into a 2D vector, or I can just use 4 variables for this. So this is one way I can do this. So for the first time it will be done. So now if I do it for the another step, it was -1 0 0 1 and 2. Now my j is here, my I is still here, and my left is here and my right is here. Okay, so this is what I have at the moment. So now my target is again 0, my sum is -2 plus 0, that is -2, and my target is 0, and so what I have to find is 0 minus minus of 2, that is 2. So I'll start from left. Is left nums of left plus nums of right less than or greater than? No, it is equal. So I found my answer, and then I'll go ahead and check, is it? No. Then I'll go ahead, is it? No. The moment my left crosses my right, I'll stop. Right, the moment my left crosses the right, I'll stop. This is what I will do, or it becomes equal. Now there is something we can observe, like we are doing some extra work here. What is that extra work? So in the previous example, when my j was somewhere around, so if I discuss, so in the previous example, when my I was here, my j was here, and my left was here and my right was here, right? We checked that for 2 and 0 we are not getting a sum of 3, so we have to move my left ahead. But when we moved our left ahead, we again have a 0 there. So isn't it like an extra work that we are again checking for the same number, and instead of checking here, we should directly go to the number which is not equal to this. So this is the extra work we have been doing. So we can omit this, right? We can omit this. I will show you in the code how we will omit this, but what we will do is we will increment our left till the value is same and it is less than right. Okay, so we will do this. Now the time complexity for this will be O of n cube, because this will be, I will be running n times, this j will be running n times, and this left is less than right will be running n times in the worst case. Okay, so the time complexity will be O of n, and the space complexity will be a constant space, that is O of 1. Right, so this is what we will do. So this is a pretty easy question if you know how to do this. So int n equals to, I have nums dot size. Now my target is given to me, and I'll just sort the array. So I'll sort it, I'll do the stl using the stl sort function. So nums dot end, so I've sorted the array here. Now I'll run 2 loops. For I will be starting from 0 and it will go till n. Now the another loop, j will be always be starting from I plus 1, and it will always be less than n, and I'll do a j plus plus. Now I will have my sum, which will be equal to target plus which will be equal to target minus, that was my mistake. So nums of I plus nums of j, this will be my target. Now my int will always be j, left will always be j plus 1, and my int right will always be n minus 1. Now till my left is lesser than the right. I'll check if nums of, so instead of doing this if nums of all the time, I'll just store int sum2 equals to nums of left plus nums of right. Why I'm calculating is it here is for the dry principle in the programming, that is do not repeat itself. So if I would have not used this, I would have write it multiple times, like if it is greater, if this value sum is less. So I have used this multiple times. Now all I have to do is use this sum2. So if my sum2 is less than sum, right, I'll do a left plus plus, I'll do a left plus plus. Now else if my sum2 is greater than sum, I'll do a right minus minus. And else if this is not the case, also I have to take a vector int answer, it will store my answer. So answer, now in there what I can do, I can take a vector of int temp of size 4 with 0, initialized with 0. So now my temp of 0 will be the value of nums of I, so it will be nums of I, and same for temp of 1 will be the value at nums of j. Now the next one will be the value at nums of left, and the last one will be the value at nums of right. And now comes the part where we will be skipping the values which comes in repetition. So what we will do is, while my left is less than right and nums of left equals to temp of 2, and in here I have to do something else, that is answer dot push back temp. So we have stored the answer. Now if this is the case, I'll do a left plus plus. Now I also have to check for the right. So while my left is less than right and nums of right is equals to temp of 3, if this is the case, I'll do a right minus minus. This is what I'm doing. Now when I come back, I'll check again for my for. So while my j plus 1 is less than n and my nums of j plus 1 is equal to nums of j. If this is the case, I'll do j plus plus. So why we are doing a j plus 1 here? Because we are having a j plus plus here, right? If you will dry run this, you will get to know why we are doing a j plus 1 here, and we will do same for an I, right? So here we will do while my I plus 1 is less than n and nums of I plus 1 equals to nums of I'll do I plus plus. Okay, so we've done this. Now in the end we have to return the answer. Now in the end, now if I run this, okay, we are having a error like temp2 is not defined. Okay, so this will be inside this else block only. This will be inside this else block, because when we find the value are same, when we find the answer, then we will skip. So now if we submit it, it should be working fine. Okay, we get a runtime error, signed integer overflow. The problem was there was an integer overflow, so I converted all this to a long int, the where I am calculating the sum, and then I submitted. So it is submitted. So if I submit it again, so you can see it is working fine. So thank you for watching the video, and make sure to hit that subscribe and like button if you enjoyed the video, and see you all in the next video.